ತಾರೀಕಿಗೆ ನಾನು ಎಲೆಕ್ಟ್ರಿಕ್ ಚಾರ್ಜಸ್ ಅಂಡ್ ಫೀಲ್ಡ್ಸ್ ಬಗ್ಗೆ ಪೂರ್ತಿಯಾಗಿ ವಿವರವಾಗಿ ನಿಮಗೆ ಪಾಠ ಮಾಡಿದ್ದೆ. ಅದರಲ್ಲಿ 2 ಪ್ರಶ್ನೆಗಳು ಬಿಟ್ಟು ಹೋಗಿದ್ವು. ಅದನ್ನ ಇವತ್ತು ನಾವು ನೋಡೋಣ. 2 ಪ್ರಶ್ನೆಗಳನ್ನ ಇವತ್ತು ಸಾಲ್ವ್ ಮಾಡೋಣ. ಅದಕ್ಕಿಂತ ಮುಂಚೆ ನಾವು ಮಾಡಬೇಕಾಗಿರೋ ಕೆಲಸ ಏನು ಅಂತಂದ್ರೆ, we have to learn about electric potentials chapter. We will go up to the end of electric potential chapter except capacitors. As far as capacitors are concerned, Professor Vigneshwar Bhatt will take it up along with the capacitor. He will also be discussing about current electricity. So that is another area where Vigneshwar Bhatt sir will be in teaching you. But my job is to take up electric potentials today. Okay, let us quickly learn some of the important aspects, some of the important points about electric potential topic. First, let us understand what is meant by electric potential. Electric potential ಅಂದ್ರೆ ಏನು? ವಿದ್ಯುತ್ ವಿಭವ ಅಂತ ಕನ್ನಡದಲ್ಲಿ ಕರಿತೀವಿ ನಾವು. ಹಾಗಂದ್ರೆ ಏನು? The ratio of the work done to bring a test charge Q0 from infinity to a given point in the external electric field with constant speed to the charge is called the potential at that point. ಹೇಗೆ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ ಅಂತಂದ್ರೆ, if we bring this charge, ಈ ಚಾರ್ಜ್ ಏನಿದೆ Q0 ಅನ್ನು ನಾವು ಇನ್ಫಿನಿಟಿ ಇಂದ ನಿಧಾನವಾಗಿ ಈ ಪಾಯಿಂಟ್ ಪೀಕ್ ತಂದಾಗ how much work do we do? Suppose I call that work done W, and if I divide this by the charge so broad, adana test charge na Q0 anta karitivi, then at the point P the potential is defined as Vp equals W divided by Q0. This goes without saying. The SI unit of electric potential is of course volt. Idana capital letter V nallu kuda baritivi. The dimensional formula of electric potential is m L square t to the power of -3 A stands for current, A to the power of -1. So that is the dimensional formula of electrostatic potential, and electrostatic potential is a scalar physical quantity. ಇದೊಂದು ಅದಿಶ, ಇದಕ್ಕೆ ದಿಕ್ಕಿಲ್ಲ. ಯಾಕೆ ಅಂತಂದ್ರೆ potential V is defined as work, which is a scalar, divided by charge, which is also another scalar. A scalar divided by another scalar is also a scalar. Now, if U stands for the electric potential energy of a charge Q0 in the external electric field, then the electric potential at the point is electric potential at the point Vp anna hೀಗೂ ಸಹ ಬರೀಬಹುದು. Vp is equal to potential energy at that point divided by the test charge. ಈ ರೀತಿನೂ ಸಹ ಬರೀಬಹುದು. ಮುಂದಕ್ಕೆ ಹೋದ ಹಾಗೆ let us talk about the potential difference between 2 points. ಈಗ potential difference between 2 points ಅನ್ನು ಹೇಗೆ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ ಅಂತಂದ್ರೆ, if the work done to bring a point charge Q0 from point A ನಿಂದ ಪಾಯಿಂಟ್ ಬಿ ತರ್ತಾ ಇದ್ದೀವಿ, ಪಾಯಿಂಟ್ ಎ ಇಂದ ಪಾಯಿಂಟ್ ಬಿ ತರ್ತಾ ಇದ್ದೀವಿ. ಜಸ್ಟ್ ಈ ಡಯಾಗ್ರಾಮ್ ಅನ್ನ ನೋಡಿರುತ್ತೆ. ಇಲ್ಲಿ ಪಾಯಿಂಟ್ ಎ ಇಂದ ಬಿ ಗೆ ನೀವು ಒಂದು ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಅನ್ನ Q0 ಅನ್ನು ತಂದ್ರೆ, how much work do you do? Let us say that work done to bring the charge from A to B. If I divide this by test charge Q0, we get a physical quantity. We call it the potential difference between the 2 points A and B. VAB we can call it. This is the final potential VB minus the initial potential VA. So this is another useful relationship. From this relationship, we can also rewrite as follows. Suppose you take a charge Q0 from point A here to point B over there, where at point A you have the potential VA and at point B you have a potential VB. Then the work done to bring the charge from A to B can be written as charge so taken times the potential difference between the 2 points. So ಇದರಲ್ಲಿ ಏನು ಆಶ್ಚರ್ಯ ಪಡ್ತಕ್ಕಂಥದ್ದು ಏನು ಇಲ್ಲ. ಯಾಕೆಂತಂದ್ರೆ ಈಗ ತಾನೇ ಒಂದು ಎಕ್ಸ್ಪ್ರೆಷನ್ ಇಲ್ಲಿ ಬರೆದಿದ್ದೆ, ಇದೇ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಅನ್ನ ರಿವರ್ಸ್ ಬರೆದ್ರೆ ಇಲ್ಲಿ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಬಿಟ್ವೀನ್ 2 ಪಾಯಿಂಟ್ಸ್ ಕೊಟ್ಟಿದ್ದಾನೆ, ಇದರಲ್ಲಿ ಇಲ್ಲಿ ವರ್ಕ್ ಕೇಳಿದ್ದಾನೆ. ಸೊ ಯು ಜಸ್ಟ್ ಹ್ಯಾವ್ ಟು rewrite it by cross multiplying q naught to the other side. Now let us consider electric potential due to a point charge. One single point charge ಏನಿದೆ ಇದನ್ನ capital Q, often we call it a source charge. ಇದನ್ನ source charge ಅಂತಾನೂ ಕರೀಬಹುದು. ಈ source charge ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡತಕ್ಕಂತ potential ಈ ಪಾಯಿಂಟ್ P ನಲ್ಲಿ ಎಷ್ಟಿರುತ್ತೆ, ಇದನ್ನ 5 ಮಾರ್ಕ್ ಡಿರೈವೇಶನ್ ಆಗಿ ನೀವು ಆಗ್ಲೇ ಅಭ್ಯಾಸ ಮಾಡಿದ್ದೀರಿ. ಅದ್ರ ಬಗ್ಗೆ ನಾನು ಏನು ಕಮೆಂಟ್ ಮಾಡೋದಕ್ಕೆ ಹೋಗೋದಿಲ್ಲ. ಇದು ಹೇಗೆ ಬರುತ್ತೆ ಅನ್ನೋದಕ್ಕಿಂತಲೂ ಅದರ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಏನಿರುತ್ತೆ ಅಂತಂದ್ರೆ the potential at point P is given by 1 divided by 4 pi epsilon naught into source charge Q divided by separation distance R. Vp equals 1 divided by 4 pi epsilon naught capital Q divided by small r. Suppose I take potential due to a point charge in the vertical axis and the radial distance from it along the horizontal axis, then if we take potential along the vertical axis and radial distance along the horizontal axis, the variation of V versus R, how does it look? You already see from this expression that Vp equals 1 divided by 4 pi epsilon naught into Q divided by R. For a given charge Q and for a given value 4 pi epsilon naught, all of those are constants. In fact, you can write V equals Q divided by 4 pi epsilon naught as a constant divided by R. Notice this variation is like y is equal to c by x. Y is equal to c by x or xy is equal to constant is always representing a hyperbola, rectangular hyperbola. And the rectangular hyperbola, as you all know, looks like that. So therefore, the potential V versus radial distance R also is a rectangular hyperbola. That is also a rectangular hyperbola. Let's now talk about electric potential due to an electric dipole. Now you see here in this diagram an electric dipole having two charges. One is plus Q, another one is minus Q. Two equal but unlike charges separated by a small distance called 2a. Then the dipole moment P is given by 2aq, which is something I had discussed in my Tuesday's class itself. P is equal to 2aq. Now, how much potential does it produce at this point P? This point P nalli our dipole ಎಷ್ಟು potential ಅನ್ನು produce ಮಾಡುತ್ತೆ. ಅದಕ್ಕೆ first of all we should know that r cap is a unit vector along the radial direction r, and P vector is the direction of the dipole moment. The angle between the two is theta. Then the potential at this point P, ಈ ಪಾಯಿಂಟ್ ನಲ್ಲಿ ಇರತಕ್ಕಂತ potential ಎಷ್ಟಿರುತ್ತೆ ಅಂತಂದ್ರೆ Vp equals 1, I'm sorry, okay, Vp equals 1 divided by 4 pi epsilon naught P vector dot r cap vector divided by r square. ಅಥವಾ P vector dot r vector ಅಂತಂದ್ರೆ P cos theta ಆಗುತ್ತೆ. ಅದನ್ನ ಹೀಗೂ ಬರೀಬಹುದು, 1 divided by 4 pi epsilon naught P cos theta divided by r square. You can keep it in both of these forms. That is the potential due to an electric dipole. Now let us find out what are the potentials at point P1 here, point P2 here, and point P3 there. ಇಲ್ಲೊಂದು ಡೈಪೋಲ್ ಇದೆ, ಆ ಡೈಪೋಲ್ ಇಂದ ಕ್ರಿಯೇಟ್ ಆಗ್ತಕ್ಕಂತ ಪೊಟೆನ್ಷಿಯಲ್ P1, P2, P3 ನಲ್ಲಿ ಎಷ್ಟಿರುತ್ತೆ. For P1 point, the r vector or r cap vector is like this. P vector is already that way. So P and R are parallel to each other. Theta is equal to 0. Theta is equal to 0. Adaga cos theta is equal to 1. The potential V1, if I call that, is 1 divided by 4 pi epsilon naught P by R. E point alli P2 nalli eshtagutte. For this point, R cap vector is that way. P vector is already this way. Angle between the two is 90 degree. Cos theta, which is cos 90, will become 0. When cos 90 is 0, cos theta is 0. The potential at this point, P2, is 0. Finally, the potential at P3. Notice this time R cap is downward, whereas P vector is always from negative charge to positive upward. So therefore theta here is 180 degree. So cos 180 or cos theta is therefore minus 1. Because of that, if you substitute that in here, you will get the potential at P3 is 1 by 4 pi epsilon naught P by R square, except one small difference, my dear students, there is going to be a negative sign. That means the potential at P1 is positive, at P2 is negative, and at P3, sorry, P2 is 0 and P3 negative. Let's proceed to the next set of concepts. Yes. Let us now explore the electric potential due to a charged spherical conductor. ಇಲ್ಲಿ ನಿಮ್ಮ ಮುಂದೆ ಒಂದು ಚಾರ್ಜ್ ಸ್ಫೆರಿಕಲ್ ಕಂಡಕ್ಟರ್ ನ ನೀವು ಗಮನಿಸಬಹುದು. ಇದರ ಮೇಲೆ ಚಾರ್ಜ್ Q ಅನ್ನು ಕೊಟ್ಟರೆ that charge resides uniformly upon the surface. Let us say capital Q is that charge and capital R is the radius of this. And we would like to find out the potential both inside, that is at point P1, and we would like to find the potential at P2, a point outside. For outside point, you can easily recognize that R is greater than capital R. For inside point, R is definitely less than capital R. So, ಈ ಎರಡು ಪಾಯಿಂಟ್ಸ್ ಗಳಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಎಷ್ಟಿರುತ್ತೆ ಅಂತಂದ್ರೆ potential V inside is given by 1 divided by 4 pi epsilon naught Q divided by R if R is less than or equal to R, greater than or equal to 0. Outside, the electric potential varies like 1 by 4 pi epsilon naught Q by small r if R is greater than 0. Sorry, greater than capital R. So, ಹೀಗಿದ್ದಾಗ electric potential ಹೇಗೆ ವೇರಿ ಆಗುತ್ತೆ? This I have already done. How does the potential vary due to a spherical conductor? ಒಂದು ಸ್ಫೆರಿಕಲ್ ಕಂಡಕ್ಟರ್ ಇದೆ, ಆವೇಶಿತ ವಾಹಕ ಗೋಳ, ಅದು ಅಲ್ಯೂಮಿನಿಯಂ ಇರಬಹುದು ಅಥವಾ ಕಾಪರ್ ಇರಬಹುದು, ಅದರ ಮೇಲೆ ಚಾರ್ಜ್ ಕೊಟ್ಟಿದ್ದೀರಿ. ಅವಾಗ ಪೊಟೆನ್ಷಿಯಲ್ ಒಳಗಡೆ ಹೇಗೆ ವೇರಿ ಆಗುತ್ತೆ, ಹೊರಗಡೆ ಹೇಗೆ ವೇರಿ ಆಗುತ್ತೆ? Inside the sphere, the potential is constant and the value is Q divided by 4 pi epsilon naught R. But ಹೊರಗಡೆ ಬಂದಾಗ the potential varies as 1 by R, rectangular hyperbola. ಹೊರಗಡೆ ಬಂದಾಗ ಅದರ ಶೇಪ್ ಹೇಗಿರುತ್ತೆ? ಸೊ ಇದನ್ನ ನೀವು ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. ಇದನ್ನ ನಿಮ್ಮ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ನಲ್ಲೂ ಕೊಟ್ಟಿದ್ದಾರೆ, ಎಲ್ಲ ಎಕ್ಸಾಮ್ಗಳಲ್ಲೂ ಬಹಳಷ್ಟು ಮುಖ್ಯವಾಗಿ ಬೇಕಾಗಿರ್ತಕ್ಕಂಥದ್ದು. ಸೊ ಯಾವತ್ತು ಇದನ್ನ ಮರಿಬೇಡಿ. ದಿ ಪೊಟೆನ್ಷಿಯಲ್ ಡ್ಯೂ ಟು ಅ ಸ್ಫೆರಿಕಲ್ ಕಂಡಕ್ಟರ್, ಚಾರ್ಜ್ಡ್ ಕಂಡಕ್ಟರ್ ವೇರೀಸ್ ದಿಸ್ ವೇ. Next, let us discuss about the equipotential surfaces. ನೀವು ಇಲ್ಲಿ ಗಮನಿಸಬಹುದು, ಇಲ್ಲಿ ಸೆಂಟ್ರಲ್ಲಿ ಒಂದು ಚಾರ್ಜ್ ಇಟ್ಟಿದ್ದಾರೆ, ಅದು ಪಾಯಿಂಟ್ ಚಾರ್ಜ್ ಪ್ಲಸ್ ಕ್ಯೂ ಅಂತ ಅನ್ಕೊಳ್ಳಿ, ಅದು ಕಾಣಿಸ್ತಾ ಇಲ್ಲ. ಅದ್ರ ಸುತ್ತಲೂ ನೀವು ಎಷ್ಟೇ ಸ್ಫೆರಿಕಲ್ ಸರ್ಫೇಸಸ್ ಗಳನ್ನ ಇಮ್ಯಾಜಿನ್ ಮಾಡ್ಕೊಳ್ಬಹುದು. ಬಹುಶಃ ನೀವು ಸ್ಫೆರಿಕಲ್ ಶೇಪ್ ಇರ್ತಕ್ಕಂಥ ಬಲೂನ್ ಗಳನ್ನ ನೀವು ಇಮ್ಯಾಜಿನ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಅದರ ಸೆಂಟ್ರಲ್ಲಿ ನಮ್ ಚಾರ್ಜ್ ಇರುತ್ತೆ. ಯಾವ್ದಾದ್ರು ಒಂದು ಸ್ಪಿಯರ್ ತಗೊಳ್ಳಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, there is a sphere here. At every point, I think that color is not visible. So at every point here, etc., the potential is the same. Therefore, that surface is called equipotential surface. Once again, if you consider any points here, here upon the outer surface or outer sphere, the potential will be the same. So therefore, for a point charge, a family of concentric spheres gives the equipotential surfaces. Now you can see another type of charge distribution here, which is infinitely long charge carrying wire, The equipotential surfaces due to it are coaxial cylinders. You can see coaxial cylinders. The potential at every point on a given equipotential surface is same. That is the meaning of equipotential surfaces. Now let us quickly learn some of the important properties of equipotential surface. ಸಮ ವಿದ್ಯುತ್ ವಿಭವ ಮೇಲ್ಮೈಗಳು ಅಂತ ಕರೀತೇವೆ ಇದನ್ನ. ಅದರ ಕೆಲವು ಬಹಳ ಮುಖ್ಯವಾದ ಗುಣಲಕ್ಷಣಗಳನ್ನ ಈಗ ಕಲಿಯೋಣ. ಒಂದು, the electric field lines are always perpendicular to the equipotential surface. ನೋಡಬಹುದು ನೀವು ಇಲ್ಲಿ ಎಲ್ಲ ಪಾಯಿಂಟ್ಸ್ ಗಳಲ್ಲೂ ನಾನು ಬರೆದಿರ್ತಕ್ಕಂಥ ಪಾಯಿಂಟ್ಸ್ ಗಳಲ್ಲೂ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಈ ಸರ್ಫೇಸ್ಗೆ ಎಲ್ಲಾ ಪಾಯಿಂಟ್ ಗಳಲ್ಲೂ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿರುತ್ತೆ, ನಾರ್ಮಲ್ ಆಗಿರುತ್ತೆ. ಎರಡನೇದು, the work done to take a charge from one point to another point on a given equipotential surface ಅನ್ನು ನಾನು EPS ಅಂತ ಕರೆದಿದ್ದೀನಿ. ದಟ್ ಇಸ್ 0. ಅಂದ್ರೆ ಒಂದು equipotential surface ಅಲ್ಲಿ ತಗೊಂಡಿದ್ದೀರಿ EPS ಇದು, ಏನಿಂದ ಬಿಗೆ ನೀವು ಒಂದು ಚಾರ್ಜ್ ಅನ್ನು ತಗೊಂಡು ಹೋಗ್ತಾ ಇದ್ದೀರಿ ಅಂತಂದ್ರೆ then the work done by you is always 0. That is the second important property. Third property, ಎರಡು equipotential surface ಅನ್ನು ನಾನು ತೋರಿಸೋದಕ್ಕೆ ಪ್ರಯತ್ನ ಮಾಡಿದ್ದೇನೆ. ಇಲ್ಲಿ ಇದೊಂದು ಸರ್ಫೇಸ್ ಆದ್ರೆ ಇದು ಇನ್ನೊಂದು ಸರ್ಫೇಸ್. ನೀವು ಇದ್ರ ಮೇಲೆ ಇರ್ತಕ್ಕಂಥ ಪೊಟೆನ್ಶಿಯಲ್ V1 ಅಂತ ತಗೊಂಡ್ರೆ, ಇದ್ರ ಮೇಲೆ ಇರ್ತಕ್ಕಂಥ ಪೊಟೆನ್ಶಿಯಲ್ V2 ಅಂತ ತಗೊಂಡ್ರೆ, ಓಕೆ, ಇಲ್ಲೆಲ್ಲ ಪೊಟೆನ್ಶಿಯಲ್ V1 ಇರುತ್ತೆ ಅಂತ ಹೇಳ್ಬೋದು. ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲೆಲ್ಲ ಪೊಟೆನ್ಶಿಯಲ್ V2 ಇರುತ್ತೆ ಅಂತ ಹೇಳ್ಬೋದು. ಆದ್ರೆ ಇಲ್ಲಿ ಎಲ್ಲದು ಇಂಟರ್ಸೆಕ್ಟ್ ಆಗುವಂತದನ್ನ ಗಮನಿಸಬಹುದು ನೀವು. ಇಲ್ಲಿ I'll use a different color now. ಇಲ್ಲಿ ಇಂಟರ್ಸೆಕ್ಟ್ ಆಗೋದನ್ನ ಗಮನಿಸಬಹುದು. ಎಲ್ಲಿ ಇಂಟರ್ಸೆಕ್ಟ್ ಆಗುತ್ತೋ ಇಲ್ಲಿ ನಿಮಗೆ ಪ್ಯಾರಾಡಾಕ್ಸ್ ಅಥವಾ ಕಾಂಟ್ರಾಡಿಕ್ಷನ್ ಉಂಟಾಗುತ್ತೆ. ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಪೊಟೆನ್ಶಿಯಲ್ V1 ಅಂತ ಕರಿತೀರೋ, V2 ಅಂತ ಕರಿತೀರೋ. V1 ಇದ್ರೆ V2 ಇರೋದಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ, V2 ಇದ್ರೆ V1 ಇರೋದಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ. ಸೊ ಇಂತ ಒಂದು ದ್ವಂದ್ವ ಸ್ಥಿತಿಯಿಂದ ಹೊರಗೆ ಬರೋದಕ್ಕೆ ಒಂದೇ ಒಂದು ದಾರಿ ಅಂತಂದ್ರೆ, ಎರಡು equipotential surfaces ಗಳು ಯಾವತ್ತೂ ಒಂದಕ್ಕೊಂದು ಛೇದಿಸೋದಿಲ್ಲ. They do not intersect each other. So two equipotential surfaces can never intersect each other. These are some of the important properties of equipotential surfaces. Let us proceed to the next set of concepts. The relation between electric field and electric potential. Now you see, you consider two equipotential surfaces. The lower one is having higher potential V. The upper surface is having lower potential V minus delta V. The separation distance between the two is delta L. Then you see electric field exists perpendicular to the equipotential surface. So if so, how much is the electric field? Electric field is given by E equals negative of potential difference delta V divided by separation distance delta L. ಇದು ಬರೀಬಹುದು. ಅಥವಾ ಎರಡು ಸೈಡ್ ಇಲ್ಲಿ ಲಿಮಿಟ್ ಹಾಕ್ಬಿಟ್ರೆ delta V by delta L ಹಾಕಿದ್ರೆ you should get minus dV by dl ಅಂತಾನು ಬರೀಬಹುದು. ಅಥವಾ in general electric field ಅನ್ನ minus dV by dx ಅಂತ ಬರೀಬಹುದು, ಅಥವಾ minus dV by dy ಅಂತ ಬರೀಬಹುದು, ಅಥವಾ minus dV by dr ಅಂತ ಬರೀಬಹುದು. ಯಾವುದೇ ಲೆಂತ್ ಪ್ಯಾರಾಮೀಟರ್ ನ ನೀವು ಬರೆದು ತೋರಿಸಬಹುದು. Suppose you draw potential at a given point along the vertical axis and distance along the horizontal axis, then let us say the graph of V versus X is like this. Then you mark a point here. You will point on the mark madi. Draw a tangent over there and find the slope of this. You know how to find the slope by now. You have done several experiments in physics where you have to find the slope of the tangent. The slope of this graph gives you dV by dx. Electric field at that point can also be written as negative of slope of tangent to V versus X graph. ಈ ಪಾಯಿಂಟ್ ಅನ್ನು ಸಹ ಅರ್ಥ ಮಾಡ್ಕೊಂಡಿರಿ. Let's now talk about potential energy of 2 or 3 charge systems in the absence of the external electric field. Suppose I have to bring this Q1 charge from infinity to A and this charge Q2 from infinity to B, then definitely in order to assemble those two charges I have done work. The amount of work done will be stored in the form of electric potential energy. Electric potential energy of 2 charge system is given by 1 divided by 4 pi epsilon naught Q1 Q2. I'm sorry, I'm using capital Q's. Epsilon naught capital Q1 capital Q2 divided by separation distance R. So that is the electric potential energy of 2 charge system. In the same way, electric potential energy of 3 charge system can also be evaluated. One thing you have to bear in mind, there is a pair over here, there is a second pair of charges over here, and there is a third pair of charges over here. So for every pair of charges to assemble, you have to do work. So that work done to assemble the 3 charges will be stored in the form of electrostatic potential energy. And after a long time, after a long derivation which you did, the expression comes out to be 1 by 4 pi epsilon naught into Q1 Q2 divided by R12 plus Q2 Q3 divided by R23 plus Q1 Q3 divided by R1. So this expression gives you the electric potential energy of 3 point charge systems in the absence of the external electric field. What happens if you have a system of 2 point charges, Q1 here and minus Q2 also here, in an external electric field? Note that at the location of Q1 you have potential V1 and at the location of Q2 you have potential V2. Therefore, the potential energy stored here is given by Q1 V1, I guess it's capital Q, Q1 V1 plus Q2 V2 plus work done to assemble these two charges as a pair, which is 1 divided by 4 pi epsilon naught Q1 Q2 divided by R. So this is the potential energy stored in a 2 charge system in the presence of the external electric field. ಬಾಹ್ಯ ವಿದ್ಯುತ್ ಕ್ಷೇತ್ರ ಇದ್ದಾಗ ಅಂತ ಬಾಹ್ಯ ವಿದ್ಯುತ್ ಕ್ಷೇತ್ರದಲ್ಲಿ ಎರಡು ಬಿಂದು ಆವೇಶಗಳನ್ನ ನಾವು ಸೇರಿಸಬೇಕಾದ್ರೆ, ಎರಡು ಬಿಂದು ಆವೇಶಗಳನ್ನ ನಾವು ಈ ರೀತಿ ಅಸೆಂಬಲ್ ಮಾಡಬೇಕಾದ್ರೆ ಅಲ್ಲಿ ಉಂಟಾಗುವಂತ ಪೊಟೆನ್ಶಿಯಲ್ ಎನರ್ಜಿ, ವಿದ್ಯುತ್ ಪ್ರಚೋದನ ಶಕ್ತಿ ಎಷ್ಟಿರುತ್ತೆ, ಪೊಟೆನ್ಶಿಯಲ್ ಎನರ್ಜಿ ಅಂದ್ರೆ ಈ ಫಾರ್ಮುಲಾದ ಮೂಲಕ ಅದನ್ನ ಕಂಡುಹಿಡಿಯಬಹುದು. Next, let us talk about the potential energy of a dipole in an external uniform electric field. You have a uniform electric field here, E, and a dipole is placed with its dipole moment at an angle theta with the direction of the field. Then the potential energy stored here, I'll use a slightly different color to have a difference, is given by minus P vector dot E vector or minus PE cos theta. So this is the formula of the potential energy stored in a dipole in an external uniform electric field. Now we have 3 situations to explore. First, the dipole moment is parallel to the electric field, in which case theta is equal to 0. And theta is equal to 0, cos theta is 1. Therefore, the potential energy stored is minimum, which is minus P times E. And this orientation is called stable equilibrium. In a stable equilibrium. Second, in the second case, you see theta is equal to 90 degree. Dipole moment is that way, whereas electric field is perpendicular to that. Theta is equal to 90, and theta is equal to 90. Cos theta is equal to 0, and cos theta is equal to 0. Please note here, when cos theta is 0, the potential energy is 0. Potential energy is 0. Last but not the least, if positive charges of the dipole is to the left and negative charges to the right, dipole moment is towards the left, and electric field is towards the right, definitely angle theta between the two is 180 degree. So definitely cos theta is going to become -1. And now if you come back to this expression, minus PE cos theta. So cos theta is already -1. Minus or minus becomes plus. So you get maximum potential energy. That is plus P. So we say in this configuration, last configuration only, potential energy of the dipole ಇದೆಯಲ್ಲ ಅದು highest ಇದ್ಬಿಡುತ್ತೆ, maximum ಇದ್ಬಿಡುತ್ತೆ. Value ಎಷ್ಟು ಅಂತಂದ್ರೆ plus P. But once again this represents another type of equilibrium. It is often called unstable equilibrium. Unstable equilibrium ಅಂತ ಕರಿತೀವಿ. ಮುಂದೆ ಹೋಗೋಣ. ಇಲ್ಲಿಗೆ ನನ್ನ ಸಿನಾಪ್ಸಿಸ್ ಮುಕ್ತಾಯ ಆಯ್ತು. ಸಿನಾಪ್ಸಿಸ್ ಮುಕ್ತಾಯ ಮಾಡಿದೀನಿ. ಇನ್ನು ನಾವು ಪ್ರಾಬ್ಲಮ್ಸ್ ತಗೊಳ್ಳೋಣ. ಪ್ರಾಬ್ಲಮ್ಸ್ ನಿಮಗೆ ವರ್ಕ್ಶೀಟ್ ಅನ್ನು ನಾನು ಆಗಲೇ ಕಳಿಸಿದ್ದೀನಿ. ನಿಮ್ಮ ಸರ್ಗಳು ನಿಮ್ಮ ಕಾಲೇಜ್ನಲ್ಲಿ ಕೊಟ್ಟಿರಬಹುದು. ಆ ವರ್ಕ್ಶೀಟ್ ಅನ್ನು ಓಪನ್ ಮಾಡಿ. ನಮಗೆ ಹಿಂದಿನ ವರ್ಕ್ಶೀಟ್ ಅಲ್ಲಿ 2 ಪ್ರಾಬ್ಲಮ್ಸ್ ಗಳನ್ನ ಬಿಟ್ಟಿದ್ವಿ. ಆ 2 ಪ್ರಾಬ್ಲಮ್ಸ್ ಗಳನ್ನ ಮೊದಲು ಸಾಲ್ವ್ ಮಾಡಿಬಿಟ್ಟು ಆಮೇಲೆ ಮುಂದಿನ ಪ್ರಾಬ್ಲಮ್ಸ್ ಗಳಿಗೆ ಹೋಗೋಣ. If there are any questions beforehand, I can answer them and then I can go for problem solving. If you have any queries or any specific questions, you can definitely ask me. ಯಾವುದೇ ರೀತಿಯಾದಂತಹ ಪ್ರಶ್ನೆಗಳು ಅಥವಾ ಏನಾದರೂ ಕೇಳೋದಿದ್ರೆ ದಯವಿಟ್ಟು ಅದನ್ನ ಈಗಲೇ ಕೇಳಿ. ಯಾವುದಾದ್ರೂ ಪಾಯಿಂಟ್ ಅನ್ನ ಕ್ಲಾರಿಫೈ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ ಮಾಡೋಣ. ಅಂತದ್ದು ಏನಾದ್ರೂ ಇದೆಯಾ? ಯಾವ್ದಾದ್ರು ರೆಸ್ಪಾನ್ಸ್ ಬಂದ್ರೆ ನಾನು ಖಂಡಿತವಾಗ್ಲೂ ಅಟೆಂಡ್ ಮಾಡ್ತೀನಿ. ಈಗಲೇ ಕೇಳಬೇಕು ಅಂತಿಲ್ಲ, ನೀವು ಮಧ್ಯದಲ್ಲಿ ಇಂಟರಪ್ಟ್ ಮಾಡಿದ್ರು ತೊಂದರೆ ಇಲ್ಲ. I will definitely attend to help you out in this regard. Any questions? I have not taught you the entire topic, that is for certain. This topic had been taught already in your colleges. In colleges ಅಲ್ಲಿ ಇದನ್ನ ಆಗ್ಲೇ ಟೀಚ್ ಮಾಡಿದ್ದಾರೆ. ನಾನು ಮಾಡಿದ ಕೆಲಸ ಏನಂತಂದ್ರೆ ಎಲ್ಲಾ ಪಾಯಿಂಟ್ಸ್ ಗಳನ್ನ ಒಂದ್ಸಲಿ ನಿಮಗೆ ಮೆಲುಕು ಹಾಕ್ಸಿರೋದಷ್ಟೇ. ಆಗ ನಿಮಗೆ ಹೌದು ಈ ಚಾಪ್ಟರ್ ನಲ್ಲಿ ಈ ಕಾನ್ಸೆಪ್ಟ್ ಬಂದಿತ್ತು, ಈ ಫಾರ್ಮುಲಾ ಬಂದಿತ್ತು, ಈ ಡಯಾಗ್ರಾಮ್ ಬಂದಿತ್ತು ಅಂತೇಳಿ ಒಂದ್ಸಲಿ ನಿಮಗೆ ನೆನ್ಪು ಮಾಡೋದಕ್ಕೆ ಈಸಿ ಆಗುತ್ತೆ ಅನ್ನೋದಕ್ಕೋಸ್ಕರ ಈ ಸಿನಾಪ್ಸಿಸ್ ಡಿಸ್ಕಷನ್ ಪಾಠ ಸಾರಾಂಶವನ್ನ ನಾನು ಒಂದ್ಸಲಿ ರಿಪೀಟ್ ಮಾಡಿರೋದು ನಿಮ್ಗೆ. ಇರ್ಲಿ, ನಿಮ್ಮಿಂದ ಯಾವುದೇ ಪ್ರತಿಕ್ರಿಯೆ ಬರದೇ ಇರೋದ್ರಿಂದ ಬಹುಶಃ ನಿಮಗೆಲ್ಲ ಅರ್ಥ ಆಗಿದೆ ಅಂತ ಭಾವಿಸ್ಕೊಂಡು ಮುಂದಿನ ಎಕ್ಸರ್ಸೈಸ್ ಗೆ ಹೋಗೋಣ. ಅದರಲ್ಲಿ ಕ್ವಶನ್ ನಂಬರ್ 14 ಆಫ್ ದ ಪ್ರೀವಿಯಸ್ ವರ್ಕ್ಶೀಟ್ ಇದ್ರೆ ಅದನ್ನ ಓಪನ್ ಮಾಡಿದ್ರಂತೆ, ಇಲ್ಲ ಅಂದ್ರೆ ಅದನ್ನ ನೀವು ಸ್ಕ್ರೀನ್ ಅಲ್ಲೇ ಕಾಣಬಹುದು. ಕನ್ಸಿಡರ್ ಟು ಕಾನ್ಸಂಟ್ರಿಕ್ spherical surfaces S1 and S2 with radii R and 2R respectively, both centered on the origin and centered at a charge Q at the origin. The relation between the flux phi1 through S1 and the flux phi2 through S2 is ಹೇಳಿದ್ದಾರೆ. ಅಂದ್ರೆ ನಮ್ಮ ಹತ್ರ ಒಂದು ಸಣ್ಣ ಚಾರ್ಜ್ ಇದೆ ಇಲ್ಲಿ. We have a charge over there and this is a point charge at the origin ಅಂತ ಹೇಳಿದ್ರೆ, okay, somewhere there that is a charge Q. Now we have two concentric spheres. ಒಂದಿದು, it is having radius R ಅಂತ ಹೇಳಿದಾನೆ. Another maybe that one. ಎರಡು ಸರ್ಫೇಸ್ ಗಳಿದೆ ಅಂತ ಹೇಳಿದ್ದಾರೆ. Okay, either radius, inner radius is R, outer one radius is 2R. So the electric field lines of this will definitely go out. Electric field line ಹೇಗೆ ಬರುತ್ತೆ ಅಂತ ನಿಮಗೆಲ್ಲ ಗೊತ್ತಿದೆ. These are the electric field lines due to a point charge. And because electric field lines go out of these surfaces, there would definitely be electric flux. Inner sphere also contributes. Inner sphere's surface name is S1. Outer surface outer sphere surface name is S2. Hagiದ್ರೆ, what is the flux? Idr ಮೂಲಕ ಪಾಸ್ ಆಗ್ತಕ್ಕಂತ magnetic electric flux phi1, idr ಮೂಲಕ ಪಾಸ್ ಆಗ್ತಕ್ಕಂತ electric flux phi2. ಹಾಗಾದ್ರೆ phi1 ಗೆ ಮತ್ತೆ phi2 ಗೆ ಏನು ಸಂಬಂಧ? So this is the key idea. What is the key idea here? Key idea to solve this problem is application of Gauss law. Gauss law ಹಾಕ್ಬಿಟ್ರೆ ಆಗೋಯ್ತು. Gauss law ಏನು ಹೇಳುತ್ತಪ್ಪ? Gauss law ಏನು ಹೇಳುತ್ತೆ ಅಂದ್ರೆ the total electric flux is equal to 1 by epsilon naught times q enclosed. ಇವಾಗ ನೋಡಿ, S1 encloses the same charge q and S2 also encloses the same charge q. Because the two enclose the same charge, we can write phi1 is equal to q by epsilon naught. Phi2 is also q by epsilon naught. Since the two are identical, we can write phi1 equals phi2. Therefore, the correct answer is this one, first one. I hope that is understood. Let us proceed towards question number 15 of the previous worksheet. Question number 15 reads, the electric field in a given region of space is given by E equals E naught into I cap plus 2j cap, where E naught equals 100 Newton per Coulomb. The flux of this field through a circular surface of radius 0.02 meter parallel to the YZ plane is nearly k times Newton meter square per Coulomb. K Newton meter square per Coulomb, where k is ಅಂತ ಹೇಳಿದ್ರೆ ಇಲ್ಲಿ k ಏನು ವ್ಯಾಲ್ಯೂ ಇದೆ? A 0.125, B 5 times 10 to minus 3, 3 0.02 and 4 3.1. ಯಾವುದು ನೋಡೋಣ? First let us try to understand what is given in the question. You have XY Z axis system. ಹೀಗಿದೆ ನೋಡೋಣ. Okay. So ಇದು x ಅಂತ ತಗೊಂಡ್ರೆ ಇದು y ಆಗಿಬಿಡುತ್ತೆ, ಇದು z ಆಗಿಬಿಡುತ್ತೆ. And our circular surface must be parallel to the xy plane. ಅಂದ್ರೆ that should be parallel to this plane. ಅದು ಹೆಂಗ ಅರ್ಥ ಮಾಡ್ಕೋತೀರೋ ನನಗೆ ಗೊತ್ತಿಲ್ಲ. ಇದಲ್ವಾ? ಹೌದು. ಈ ಹೈಲೈಟೆಡ್ ರೀಜನ್ ಏನಿದೆ ದಟ್ ಇಸ್ XY ಪ್ಲೇನ್ ಅಲ್ವಾ? ಇದು XY ಪ್ಲೇನ್ ಇದು. ಈಗ ನಾವು ತಗೊಳ್ತಕ್ಕಂತ ಸರ್ಕ್ಯುಲರ್ ಸರ್ಫೇಸ್ ಏನಿದೆ ದಟ್ ಶುಡ್ ಬಿ ಪ್ಯಾರಲಲ್ ಟು ದಿಸ್. ಇದಕ್ಕೆ ಪ್ಯಾರಲಲ್ ಆಗಿರ್ಬೇಕು. ಇನ್ನಷ್ಟು ಚೆನ್ನಾಗಿ ಕಾಣಿಸೋದು ಇದ್ರೆ ಸ್ವಲ್ಪ ಟೈಮ್ ತಗೊಂಡು ಚೆನ್ನಾಗಿದೆ. ಸೊ ಇದು ಸರ್ಕ್ಯುಲರ್ ಫೇಸ್ ಅನ್ನು ತೋರಿಸ್ತಾ ಇದ್ದೀನಿ ನಾನು. A circular face. Notice the unit vector to the area is along the z axis. This is the unit vector. So therefore area vector is equal to area magnitude, which is pi r square, times unit vector along the z axis, which we often write k cap. Pi 3.14 into r ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾನೆ? ರೇಡಿಯಸ್ ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾನೆ ಇಲ್ಲಿ? 0.02. ಅದನ್ನ 2 into 10 to the power minus 2 ಅಂತ ಬರ್ಕೋಬಹುದು ಸ್ಕ್ವೇರ್. So 4 3s are 12, so 12. 0.56 into 10 to the power minus 4 meters square. And the diameter of that is along k cap into k. Now we have to find the electric flux through that. You know, electric field is given by E naught I cap plus 2 E naught J cap. E naught value 100 and put it in. So 100 I cap plus 200 J cap. Therefore, the electric flux, which is dot product of E vector dot A vector, E into 100 I cap plus 200 J cap, ಅಥವಾ ಪ್ಲಸ್ ಇದನ್ನು ಕೂಡ ಮಾಡಬಹುದು ಹಾಗೆ ತರ್ತೀನಿ ಇದನ್ನು ಹೇಗೋ ಬರೆಯಬಹುದಿತ್ತು ನಾವು 200 J cap plus 0 K cap ಅಂತ ಬರೆಯಬಹುದು ಅಲ್ವಾ 0 K cap dot ನೋಡಿ the area is 0 I cap plus 0 J cap plus ಇಲ್ಲಿರ್ತಕ್ಕಂಥ value 12.56 into 10 to the power of minus 4 K cap. You know how to take the dot product between the two. You have to multiply I cap coefficients on both the sides. You have to multiply J cap coefficients on both the sides. You have to multiply K cap coefficients on both the sides and add them all up algebraically. So 100 into 0 plus 200 into 0 plus 0 into 12.56 or something. So altogether that will give you 0. So none of the four choices match here. Oh, I am extremely sorry. It should have been along YZ plane. I will accordingly change the question from. Otherwise, I'll have to do the whole sum all over again. We'll make this like XY plane. Then the answer is 0. Otherwise, if it is along YZ plane, no problem. You can change that again. If it is along YZ plane, idu X, idu Y, idu Z. The circular surface is like that. Now, the area vector is definitely along the x-axis. The area vector is along the x-axis that way. Area vector is 12.56 into 10 to the power minus 4 meters squared in the I cap direction. So this time, if you work it out, the electric flux is going to be E vector dot A vector. E vector on 100 I cap plus 100 J cap, sorry, 200 J cap and further dot A vector is 12.56 into 10 to minus 4 I cap plus 0 J cap and further. So you can multiply 100 into this much plus 200 into this much. So that will give you 100 into 12.56 or the 12.56 into 10 to the power minus 2 Newton meter square per coulomb. ಅಥವಾ ಇದನ್ನು 0.125 ಬರೀಬಹುದು ಅಥವಾ 0.13 Newton meter square per coulomb. So the answer among the four is approximately this one. First one would be the answer. If you take the XY plane, that would be 0. If you take YZ plane as per the previous question, answer will be 0.125. We shall now come to the present chapter's questions. Each adhyayಕ್ಕೆ ಸಂಬಂಧಪಟ್ಟ ಕ್ವೆಶ್ಚನ್ಗಳನ್ನು ಸಾಲ್ವ್ ಮಾಡೋಣ. The first question here reads, in the following figure, the electrostatic potential due to a point charge is sketched against the distance from it to any point around it. Then the charge in microcoulomb is ಕೇಳಿದ್ದಾರೆ. ಮೈಕ್ರೋಕೂಲಂಬ್ ನಲ್ಲಿ ಆ ಚಾರ್ಜ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕಾಗಿದೆ. ಯಾವುದೋ ಒಂದು ಚಾರ್ಜ್ ಇದೆಯಂತ ಹೇಳಿ ಅದನ್ನ Q ಅಂತ ಕರೆಯೋಣ. ಅದು ಎಷ್ಟು ಅಂತ ಗೊತ್ತಿಲ್ಲ. ಅದರಲ್ಲಿ ಡಿಸ್ಟೆನ್ಸ್ R is equal to 3 ಮೀಟರ್ ಆದಾಗ ಇಲ್ಲಿ ತೋರಿಸ್ತಾ ಇದೆ ನೋಡಿ. R is equal to 3 ಮೀಟರ್ ಆದಾಗ the potential at this point, ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ V ಎಷ್ಟು ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾನೆ 3 ಕಿಲೋವೋಲ್ಟ್ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾನೆ 3 ಕಿಲೋವೋಲ್ಟ್ ಅಂದ್ರೆ 3 into 10 to the power 3 ವೋಲ್ಟ್ ಹಾಗಿದ್ರೆ Q ಎಷ್ಟು ಬರುತ್ತೆ how do we find this very easy just to recall what I told a little while ago potential due to a point charge is V equals 1 by 4 pi epsilon naught Q divided by R among this Q is to be found so Q equals V times R forgive me for writing it this way I think you would have understood why I have written that way for my convenience. You know, V is 3 kilo, 3 into 10 to the power of 3. R is 3 divided by 1 by 4 pi epsilon naught value itself is known as 9 times 10 to plus 9. My dear students, 3 3s are 9 and that 9 in the numerator and denominator cancel out, leaving you with 10 to minus 9 going to the top, 10 to plus 9 going to the top. 10 to minus 9 10 to minus 9 into 10 to plus 3 will give you 10 to minus 6 coulomb which is like 1 micro coulomb so answer is third one that was easy wasn't it let us proceed to the next question three charges capital Q and small q as you can see in the diagram capital Q here, and small q here are on the circumference of a circle of radius capital R as shown in the figure. The two charges capital Q subtend an angle 90 degrees at the center of the circle. The charge Q is symmetrically placed with respect to the charge capital Q. If the total electric potential at the center of the circle is 0, then the magnitude of the charge capital Q that capital Q has to be expressed in terms of small q. ಹೇಗೆ ಮಾಡೋಣ ನಮಗೆ ಪ್ರತಿ ಒಂದು ಚಾರ್ಜ್ ಈ ಸೆಂಟರ್ ನ O ಅಂತ ಕರೆಯೋಣ ಬೇಕಿದ್ರೆ ಆ ಸೆಂಟರ್ ನಲ್ಲಿ ಎಷ್ಟು ಪೊಟೆನ್ಶಿಯಲ್ ಕ್ರಿಯೇಟ್ ಮಾಡುತ್ತೆ ಅಂತ ಗೊತ್ತು ಫಾರ್ಮುಲಾ ಗೊತ್ತಿದೆ ನಮಗೆ ಮತ್ತೆ ಏನ್ ಹೇಳ್ತಾ ಇದ್ದಾರೆ ಅಂತಂದ್ರೆ ಆ ಮೂರು ಚಾರ್ಜಸ್ ಗಳ ಜೊತೆ ಸೇರಿ ಪಾಯಿಂಟ್ O ನಲ್ಲಿ 0 ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಶಿಯಲ್ ಅನ್ನ ಕ್ರಿಯೇಟ್ ಮಾಡುತ್ತಂತೆ ಹಾಗಿದ್ರೆ ಟೋಟಲ್ ಪೊಟೆನ್ಶಿಯಲ್ ಅಟ್ O ಸೊಲ್ಯೂಷನ್ total potential at O is potential due to this charge, my dear students, which is capital Q divided by 4 pi epsilon naught R plus potential due to this charge here, which is Q divided by 4 pi epsilon naught R, epsilon naught into capital R, plus potential due to this charge, small q there, which is again small q, which is again small q divided by 4 pi epsilon naught r. And according to the question, that is finally equal to 0. So definitely denominators may multiply both the sides by 4 pi epsilon naught capital R. So they anyway cancel. So the numerator adds up to 2q plus small q is equal to 0 or capital Q is equal to minus q by 2. So magnitude of the charge though, magnitude of the charge only is required. Magnitude of the charge, which is the modulus, which is simply q by 2. So the answer is first one itself. Let us proceed now to the next problem. I think that is mostly done. Let's go to the next problem here. Question number 3. 4-point charges capital Q, small q and q dash are to be placed on the corners of a square. If the total potential at the center P has to be 0, then which of the following is not true ಅಂತ ಕೇಳಿದ್ರೆ ಯಾವುದು ಇದರಲ್ಲಿ ಸರಿಯಾಗಿರೋ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅಲ್ಲ ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾನೆ. ನಾವೇನ್ ಮಾಡೋಣ ಇಲ್ಲಿ ಒಂದು ಸ್ಕ್ವೇರ್ ಬರೆಯೋಣ. ಆ ಸ್ಕ್ವೇರಿನ 4 ಬದಿಗಡೆ ಅದಕ್ಕಿಂತ ಮೊದಲು ನಾವೊಂದು ಕೆಲಸ ಮಾಡಬೇಕಾಗಿದೆ ಏನಂತಂದ್ರೆ ಇದರ ಡಯಾಗನಲ್ಸ್ ಅನ್ನು ಬರೆದು ತೋರಿಸಬೇಕಾಗಿದೆ. ತೋರಿಸ್ತಿದೀವಿ. ಡಯಾಗನಲ್ ಇದೆ. ಇಲ್ಲಿ ಮಧ್ಯದಲ್ಲಿ ನಾವು ಒಂದು 4 ಚಾರ್ಜ್ಗಳನ್ನು ಇಟ್ಟಿದ್ದೀವಿ. ಇಲ್ಲೊಂದು 4 ಚಾರ್ಜಸ್ ಗಳನ್ನು ಇಟ್ಟಿದ್ದೀವಿ ಈಗ. So 4 charges have been placed. And you know what those 4 charges are? This is capital Q, small q, and this is Q dash. And the distance from, and we have to find actually what is given, the total potential at point P, the center of the square is 0. ಇಲ್ಲಿರ್ತಕ್ಕಂಥ potential 0 ಅಂತ. ಅಲ್ಲಿರ್ತಕ್ಕಂಥ potential 0 ಆಗಬೇಕಾದ್ರೆ ಏನೆಲ್ಲ ಆಗಬೇಕು? Potential due to each charge must add up to 0. ಅಂದ್ರೆ solution potential at P is 0 ಅಂತಂದ್ರೆ 1q divided by 4 pi. ಈ distance ಅನ್ನು r ಅಂತಾನೆ ಕರೆಯೋಣ. What is, we don't have to even find that. Distance from each charge, say A, B, C and D. A to P, B to P, C to P, D to P are all same. ಅದನ್ನ r ಅಂತ ಕರೆಯೋಣ. So q divided by 4 pi epsilon naught r plus q divided by 4 pi epsilon naught r plus small q divided by 4 pi epsilon naught r plus q dash divided by 4 pi epsilon naught r. And according to him, the total potential at the point P is 0. Definitely, you can multiply both the sides by 4 pi epsilon naught small r, thereby cancelling off the denominator. The numerator, only this stays, 2q plus q dash equals 0. So therefore, q plus q dash, or q dash plus q is equal to minus 2q. So therefore, the first choice is correct, but that is not the answer. What we have to identify is which is not true. The first statement is true. Then, if q is equal to minus 3q, q dash is equal to q. Q dash is equal to capital Q. Q is equal to minus 3q. According to this expression, q dash under capital Q minus 3q is equal to minus 2q. Correct. This expression will be satisfied very, very easily, because for these choices, this choice of q and q dash, q plus q dash becomes minus 2q. So that is absolutely correct. Now do the same thing here as well, and you will get if for this set of charges, I will leave that as a homework for you. For these set of charges also, you can prove that q dash plus q is equal to minus 2q. Now the fourth choice indicates the total electric field. EP stands for the electric field at point P0. That is certainly not going to be 0. The potential here may be 0, but the field is not 0. Therefore, the incorrect statement is this one. The correct option here is option number 4. Let us now move towards our next question. Here we go. The separation of two charges of an electric dipole doubles, and the distance from its center to a point on its axis halves. Then the magnitude of the potential at the point, assume that the dipole length is very much less than the distance between the midpoint of the dipole to the point on its axis. So, illon dipole ide, a sun dipole, for all practical purpose, this is a short dipole actually. Sun dipole ide. This is the axis of it. Is axis. That is the axis. You have a point here, P. The distance from the dipole to the point P is called R. The dipole length, the dipole length is 2a. You know, the electrostatic potential due to an electric dipole expression ಗೊತ್ತಿದೆ ನಮಗೆ. Electric potential due to dipole is 1 divided by 4 pi epsilon naught P cos theta, but at any point on the axis, the expression for the potential is 1 by 4 pi epsilon naught P divided by R square. But P is equal to 2AQ. So 1 divided by 4 pi epsilon naught 2AQ divided by R square. ಇಲ್ಲಿ ಬದಲಾಗ್ತಿರ್ತಕ್ಕಂಥದ್ದು ಏನು ಅಂತಂದ್ರೆ ಎ ಮತ್ತೆ ಆರ್ ಮಾತ್ರ. ಸೊ ಅದಕ್ಕೋಸ್ಕರ ನಾವು ಉಳಿದಿದ್ದನ್ನೆಲ್ಲ ಕಾನ್ಸ್ಟೆಂಟ್ ಅಂತ ತಗೊಳ್ಳೋಣ. ಯಾವ್ದು ಕಾನ್ಸ್ಟೆಂಟ್? ಇವೆಲ್ಲ ಕಾನ್ಸ್ಟೆಂಟ್. ಸೊ ಯಾವ್ದು ಕಾನ್ಸ್ಟೆಂಟ್ ಅಲ್ಲ ಅಂದ್ರೆ ಎ ಮತ್ತೆ ಆರ್ ಸ್ಕ್ವೇರ್. ಸೊ ವಿ ಕ್ಯಾನ್ ಸೇ therefore v is proportional to a by r square. That implies v dash by v. v dash ಅಂದ್ರೆ ಈ ಡೈಪೋಲ್ ಲೆಂತ್ ಅನ್ನ ಡಬಲ್ ಮಾಡಿ ಆರ್ ಅನ್ನ ಅರ್ಧ ಮಾಡಿದಾಗ ವಸ್ತಿಯನ್ ಪೊಟೆನ್ಶಿಯಲ್ ಬರುತ್ತೋ ಈ ಪಾಯಿಂಟ್ ಪಿ ನಲ್ಲಿ, ಆ ಪೊಟೆನ್ಶಿಯಲ್ ಅನ್ನ ವಿ ಡ್ಯಾಶ್ ಅಂತ ಕರೆದು ಮೊದಲಿದ್ದ ಪೊಟೆನ್ಶಿಯಲ್ ವಿ ಅಂತ ಕರೆದ್ರೆ ವಿ ಡ್ಯಾಶ್ ಬೈ ವಿ ಇಸ್ ಎ ಡ್ಯಾಶ್ ಬೈ ಎ ಇಂಟು ಆರ್ ಬೈ ಆರ್ ಡ್ಯಾಶ್ ಹೋಲ್ ಸ್ಕ್ವೇರ್. ಈಗ ಅವನೇನ್ ಹೇಳ್ತಾ ಇದ್ದಾನೆ ಇಲ್ಲಿ, if the separation between the two charges of the dipole doubles ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾನೆ ಅಂದ್ರೆ therefore a dash is equal to 2a ಆಗ್ಬಿಡುತ್ತೆ. ಆಮೇಲೆ ಏನು, the distance from the midpoint to the point P r halves ಅಂದ್ರೆ r dash becomes r by 2. So ಈ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಅಲ್ಲಿ ಅದನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋಣ, ನೋಡೋಣ ಏನ್ ಬರುತ್ತೆ ಅಂತ. That gives us v dash by v is equal to a dash ಅಂತಂದ್ರೆ 2a divided by a, r ಅಂದ್ರೆ r, r dash ಅಂದ್ರೆ r by 2 whole square. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, a ಮತ್ತೆ a ಕ್ಯಾನ್ಸಲ್ ಆಗ್ಬಿಟ್ಟು r ಮತ್ತೆ r ಕ್ಯಾನ್ಸಲ್ ಆಗ್ಬಿಟ್ಟು this 2 in the denominator goes to the numerator. 2 squared in the 4 2s are 8, so 8. That means v dash is equal to 8 times v. So ಏನಾಗುತ್ತೆ, new potential becomes 8 times the original. Did you understand? Let us move to the next question, question number 5. Figure shows some equipotential surfaces or equipotential lines or surfaces. These surfaces are perpendicular to the plane of the figure. Lines distributed in space. A charged object moves from point A to B. Now, we got to find which among the four choices or statements are correct. The work done in figure 1 is greatest. The work done in the figure 2 is least. The work done is the same for figure second and third and first, second and third. The work done in figure 3 is greater than figure 2 but equal to that in figure 1. Let's do one thing. Basically, we are moving the charge from A to B. ಇಲ್ಲಿಂದ A ಇಂದ B ಹೋಗುತ್ತೆ. ಇಲ್ಲೂ ಅಷ್ಟೇ A ಇಂದ A ಪಾಯಿಂಟ್ ಇಲ್ಲಿಗಿದೆ, B ಹೋಗುತ್ತೆ. ಇಲ್ಲೂ ಅಷ್ಟೇ A ಇಂದ B ಹೋಗುತ್ತೆ. ಮೂರು ಕೇಸ್ಗಳನ್ನ ಕೊಟ್ಟಿದ್ದಾನೆ ನಮಗೆ. We know how much is the work done when the charge is moved from one point to another point. One point to another point. ಈ ಪಾಯಿಂಟ್ ನಾವು ಸಿನಾಪ್ಸಿಸ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಓದಿದ್ವಿ. W is equal to charge times potential difference, VV minus VA. So in the first case ಅಲ್ಲಿ VB ಅಂತಂದ್ರೆ 40 volt, VA ಅಂತಂದ್ರೆ 20 volt. So therefore W is equal to charge ಹಾಗೆ ಇರಲಿ, ಏನೇನು ಚಾರ್ಜ್ ಇರಲಿ, VB is equal to 40 minus 20. So that will give you 20 Q. ಆಮೇಲೆ ಸೆಕೆಂಡ್ ಕೇಸ್ ಇಲ್ಲಿ ನೋಡೋಣ. ಈ ಕೇಸ್ ಅಲ್ಲಿ ಫಿಗರ್ 2 ನಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ, so W is equal to charge times potential. Final potential ಇಲ್ಲಿದೆ B, ಅದು 40 volt minus A ಅಂದ್ರೆ 20 volt. So 40 minus 20, that also will give you 20 Q. ಅಂದ್ರೆ the work done in the first and second case will be the same. What about in the third case? ಇಲ್ಲಿ ಈ ಕೇಸ್ ನಲ್ಲಿ ಎಷ್ಟು ವರ್ಕ್ ಆಗುತ್ತೆ? Once again, work done is equal to charge times potential at B is 40 volt, potential at A is 20 volt. So 40 minus 20, once again 20. That means the work done is the same in figure 1, 2 and 3. So therefore the answer is 3. Very easy one. Let us move towards question number 6. A charge or electric charge of 8 millicoulomb, 8 millicoulomb is located at the origin. The work done by the external force taking a small charge minus 2 nanocoulomb from a point 0, 0, 3 to 0, 4, 0 via a point 0, 6, 9 centimeter is ಅಂತ ಹೇಳಿದ್ರು. So basically it is a three-dimensional idea. I don't know how you will be able to think about it. So this is your x-axis. Oh. This is your x-axis, this is your y-axis, and this is your z-axis. Now you know which point is which one. 0, point P is at 0, 0, 3. This is point P. 0, 0, 3. Right? And 0, 4, 0. This is point Q. 0, 4, 0. All are in centimeter. And 0, 6, 9. 0, 6, 9. The point is in the YZ plane. YZ plane. YZ plane. So the point happens to be somewhere here. Not here, somewhere here. This point is R, 0, 6, 9. Now what you should be doing is you have to take a point charge of minus 2 nanocoulomb and move the charge from P to Q via R. ಒಂದು ಆ ಚಾರ್ಜ್ ಎಷ್ಟು ಅಂತ ಹೇಳಿದಾನೆ? The charge that you have to take in your hand. ಈ ಚಾರ್ಜ್ ಇದೆಯಲ್ಲ, ಆ ಚಾರ್ಜ್ ಎಷ್ಟು ಅಂತ ಹೇಳಿದ್ರೆ Q0 ಅಂತ ಕರೆದ್ರೆ that is 2 minus 2 nanocoulomb. ಆ ಚಾರ್ಜ್ ಅನ್ನು ನೀವು P ಪಾಯಿಂಟ್ ಇಂದ Q ಪಾಯಿಂಟ್ ಗೆ ತರಬೇಕು. ಎಷ್ಟು ವರ್ಕ್ ಆಗುತ್ತೆ? How much is the work that you have to find out? Easiest way to do this problem is first find the potential at point P. After all, what lies here at the origin? That is the charge capital Q, and it is given by 8 millicoulomb. 8 millicoulomb. So let us find the potentials at P and Q. Potential at P is 1 by 4 pi epsilon naught into Q divided by, I shall call it OP. That is 9 times 10 to 9 into 8 millicoulomb, 8 into 10 to minus 3 divided by R. R is 3 centimeter. 3 into 10 to minus 2. So this will give you 3 ones are, 3 threes are, so 3 eights are 24. So you get 24 into 10 to the power minus 8 volt. I'm sorry, plus 10 volt. This is 3 8s are 24, 24 and 9, 6, yes, plus 8 volt. 24 into 10 to plus 8 volt. And what is the potential at Q? E point only, potential is 2. That is 1 divided by 4 pi epsilon naught, Q divided by OQ, which is 9 into 10 to 9 times 8 into 10 to minus 3 divided by the distance from O to Q is 4 centimeters. So 4 times 10 to minus 2. This will give you 4 ones are 4 twos are. So you get 18 into 10 to the power of 8 volt. So now you are taking the charge from P to Q. So how much work do you do? So work done is equal to charge Q naught taken. So final point is Q minus initial point is P. So VQ minus VP. Q naught ಅಂತಂದ್ರೆ minus 2 nano coulomb, minus 2 into 10 to the power minus 9. VQ ಅಂತಂದ್ರೆ 18 into 10 to the power of 8 minus VP ಅಂತಂದ್ರೆ 24 into 10 to the power of 8. So ಹೇಗಿಟ್ರೆ 18 minus 24 is minus 6. Minus 6 2s are plus 12. 12 into 10 to minus 1. So 1.2 joules. So the answer is second one. This problem was a little difficult one because of somewhat intricate 3D geometry involved. But that is quite a likely question in CET as well as in NEET and other examinations. Question number 7. The electric potential due to a charged spherical conductor of radius r at a distance small r from its center, where r is greater than capital R, is V naught. ನನಗೆ ಡಿಸ್ಪ್ಲೇ ಮಾಡಕ್ ಆಗ್ತಾ ಇಲ್ಲ 4 ಚಾಯ್ಸಸ್ ಗಳನ್ನ. ಅದು ಈಕ್ವೇಶನ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬಂದಿತ್ತು, ನಾನು ಅದನ್ನ ಪೇಂಟಿಂಗ್ ಹಾಕ್ಬೇಕಾದ್ರೆ 4 ಚಾಯ್ಸಸ್ ಗಳು ಹೊರಟೋದು. ಆದ್ರೂ ಕೂಡ ನಿಮಗೆ ಕೊಟ್ಟಿರ್ತಕ್ಕಂಥ ಹ್ಯಾಂಡ್ ಔಟ್ ಏನಿದೆ, ಪ್ರಿಂಟ್ ಔಟ್ ಏನಿದೆ, ಆ ಪ್ರಿಂಟ್ ಔಟ್ ನಲ್ಲಿ 4 ಕೂಡ ನಾವು ಪ್ರಿಂಟ್ ಮಾಡಿದೀವಿ, ಅದನ್ನ ಗಮನಿಸಿ. The surface charge density on the sphere is ಅಂತ ಕೇಳಿದ್ದೀನಿ. ನಮಗೆ potential due to a spherical conductor at a point outside it. ನಿಮಗೆ ಗೊತ್ತಿದೆ, ಇದು ರೇಡಿಯಸ್ r ಇದೆ. ಈ ಪಾಯಿಂಟ್ P, if it is a distance r away, the potential here at point P is given by 1 by 4 pi epsilon naught q by small r ಆಗಿದೆ ಅಂತ ಗೊತ್ತಿದೆ ನಮಗೆ. So, and suppose surface charge density is sigma, then we also know sigma is given by charge upon the sphere divided by 4 pi r square, charge divided by surface area r square is ಗೊತ್ತಿದೆ. Furthermore, potential at the point P outside is also known, which is 1 divided by 4 pi epsilon naught q divided by r. ಒಂದು ಕೆಲಸ ಮಾಡೋಣ, multiply numerator by r square and denominator by r square. And second, we shall divide this q divided by 4 pi r square. That will give you sigma. Or sigma ಕೊಡುತ್ತೆ. ಉಳಿದಿರುತ್ತೆ ಏನು ಉಳಿಯುತ್ತೆ? V is equal to sigma r square divided by epsilon naught r small r. ನಮಗೆ ಬೇಕಾಗಿರೋದು ಸಿಗ್ಮಾ. ಸಿಗ್ಮಾವನ್ನು ಒಂದು ಕಡೆ ಇಡೋಣ. V naught ಅಂತ ಹೇಳಿದಾನೆ, ಪೊಟೆನ್ಷಿಯಲ್ V naught ಅಂತ ಹೇಳಿದಾನೆ. So therefore sigma happens to be epsilon naught V naught r divided by capital R square. So ಯಾವುದು ಕರೆಕ್ಟ್ ಚಾಯ್ಸ್ ಇದೆ ಅಂತ ನೋಡ್ಕೊಂಡು ಅದನ್ನ ಬರೀರಿ. ಬಹಳ ಸಿಂಪಲ್ ಆಗಿದೆ ಇದು, ಜಸ್ಟ್ ಮ್ಯಾನಿಪುಲೇಷನ್. ಕೊಟ್ಟಿರೋ ಈ 2 ಎಕ್ಸ್ಪ್ರೆಷನ್ ಅನ್ನ ಮ್ಯಾನಿಪುಲೇಟ್ ಮಾಡಿ ನಿಮಗೆ ಬೇಕಾಗಿರೋ ಫಾರ್ಮ್ ಅಲ್ಲಿ ನೀವು ಇಡಬೇಕು ಅದನ್ನ. Question number 8. A point charge Q naught and mass m is taken from a point A to another point B on an equipotential surface having a potential V naught upon it. If its speed at A was 0 and its speed at point B is V, the work done on the charge is on the ಇದನ್ನ ಬೇಕು ಅಂತ ನಿಮಗೆ ಕನ್ಫ್ಯೂಸ್ ಮಾಡೋದಕ್ಕೆ ಹೇಳಿದ್ದೀನಿ. So you know the work done solution. ಇದು ಫಸ್ಟ್ ಇಯರ್ ಮೆಕ್ಯಾನಿಕ್ಸ್ ನಲ್ಲಿ ಹೇಳ್ಕೊಟ್ಟಿರ್ತಾರೆ ನಿಮಗೆ. Total work done is equal to change in potential energy plus change in kinetic energy. Change in potential energy is charge so taken Q naught into the potential difference, but change in kinetic energy is half mvb square minus half mva square. Ivaga, this is very important. When you take the charge from A to B on a given equipotential surface, potential at A is exactly equal to potential at B, and therefore potential difference delta V between A and B is 0. So that makes Q naught times 0 for the first one plus half m. Potential, the speed at B is mentioned to be small v. Speed at B is mentioned to be small v, v square, minus half times mass times, speed at A is 0. 0 square. So this time term vanishes, this term vanishes, first time third terms vanish. So So the work done only has half mv square. I'm extremely sorry. One of the 2 was there in all the 4 choices. 2 is there. I'm sure you can check that in your worksheet. 2 is printed on the screen. The fraction has not come. Kindly forgive for that. So 2 is already there. So answer is therefore D. Nalaknedu correct choice agutte. Let us now proceed towards problem number 9. Problem number 9 says the variation of electric potential with the x-axis is depicted as shown in the figure. The electric field in the region between x equals 0 to x equals 4 meter is, or x equals 0 to x equals 4 meter. ಈ region ಅಲ್ಲಿ ಎಷ್ಟು ನಿಮಗೆ ಆಗತಾನೆ ಹೇಳಿದ್ದೀನಿ ನಾನು. The electric field E is equal to negative of slope of V versus x graph. ಸ್ಲೋಪ್ ಹೇಗೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದು ಸರ್? ನಾವು ಒಂದು ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಅನ್ನು ಬರಿತೀವಿ. ಆ ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಟ್ಯಾಂಜೆಂಟ್ ಆಗಿರುತ್ತೆ. ಅದು ಸ್ಲೋಪ್ ಹೇಗೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀವಿ ಅಂತಂದ್ರೆ ಇದು ವರ್ಟಿಕಲ್ ಡಿಸ್ಟೆನ್ಸ್ ಅನ್ನ, ಈ ರೈಟ್ ಆಂಗಲ್ ಟ್ರಯಾಂಗಲ್ ವರ್ಟಿಕಲ್ ಡಿಸ್ಟೆನ್ಸ್ AB should be divided by horizontal distance BC. So that is negative of slope ಅಂತಂದ್ರೆ vertical distance is 20, horizontal distance is 4. So you get minus 5 volt per meter. If minus 5 volt meter, then definitely it is 5 volt per meter along negative x direction or negative x axis. So the answer is 5 volt per meter along the negative x axis. Answer number 4. Let's now proceed towards question number 10. Hatne problem ಗೆ ಬರೋಣ. The electric potential in region of space is varying with y according to y equals 3y square minus 2, where y is in meter and v is in volt. The electric field at y equals 2 meter is, ನಿಮಗೆ ಇಷ್ಟೊತ್ತಿಗೆ ಫಸ್ಟ್ ಇಯರ್ PUC ನಲ್ಲೂ ಸೆಕೆಂಡ್ ಇಯರ್ PUC ನಲ್ಲೂ ಸಾಕಷ್ಟು ಕ್ಯಾಲ್ಕುಲಸ್ ಅನ್ನು ಹೇಳ್ಕೊಟ್ಟಿದ್ದಾರೆ. ಅದ್ರ ಜೊತೆ ಡಿಫರೆನ್ಸಿಯೇಷನ್ ಅನ್ನುವಂಥದ್ದನ್ನ ಖಂಡಿತವಾಗಲೂ ನಿಮಗೆ ಫಸ್ಟ್ ಇಯರ್ ಇಂದಲೇ ಬಂದಿರೋದ್ರಿಂದ ಸಾಕಷ್ಟು ಅದ್ರ ಬಗ್ಗೆ ನಿಮಗೆ ಅರಿವಿದೆ. ಸಿಂಪಲ್ ಫಂಕ್ಷನ್ಸ್ ಗಳನ್ನ ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡೋದ್ರ ಬಗ್ಗೆ ನಿಮ್ಗೆ ಹೇಳ್ಕೊಡ್ಬೇಕಾಗಿಲ್ಲ. ಇಲ್ಲಿ ನಮಗೆ ಬೇಕಾಗಿರೋದು ಏನಂತಂದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಟ್ y is equal to 2 meter ಅಂತ ಕೇಳಿದ್ರೆ ಹೇಗೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋಣ? ವೆರಿ ಈಸಿ. ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ E is equal to negative of dv by dx ಅಂತ ಬರೀಬಹುದು ಅಥವಾ dv by dy ಅಂತ ಬರೀಬಹುದು. That is electric field E equals minus dy dy of, ಇಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡಿ, 3y squared minus 2. So our differentiation of the first term will give you 6y. Differentiation of the second term will give you 0. So minus 6y. So at y is equal to 2 meter, the electric field is therefore minus 6 into 2 will give you minus 12 volt per meter. ಅಥವಾ minus sign ಇರೋದ್ರಿಂದ ಇದನ್ನ 12 volt per meter along negative y direction. So the answer is 12 volt per meter along negative y direction. Answer is 4. Very easy again. Let us proceed towards question number 11. This problem might sound a little harder one compared to the rest of the problems, but you don't have reason to worry. Here is a simple way of solving it. You know, an electric field of 25 I cap plus 30 J cap in Newton per coulomb exists in a region of space. If the potential at the origin is taken to be 0, then the potential at x is equal to 2 meter and y is equal to 2 meter is ಅಂತ ಕೇಳಿದ್ರು. ನೋಡಿ, ನಿಮಗೆ ಈ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಅಂತೂ ಗೊತ್ತಿದೆ. ಏನ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಅದು? E equals minus dv by dr. ಅದೇ dv ಅನ್ನ ಒಂದ್ ಕಡೆ ಇಟ್ಬಿಟ್ಟು dr ಅನ್ನ ಆಚೆ ಕಡೆ ತಗೊಂಡ್ರೆ ಮೈನಸ್ e into dr ಆಗುತ್ತೆ. ಅಥವಾ ಸ್ಟ್ರಿಕ್ಟ್ಲಿ ಸ್ಪೀಕಿಂಗ್ E ವೆಕ್ಟರ್ ಡಾಟ್ dr ವೆಕ್ಟರ್ ಆಗುತ್ತೆ. ಸೊ ಎರಡು ಕಡೆ ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಿದಾಗ ಇಂಟಿಗ್ರಲ್ ಆಫ್ dv is equal to minus integral of E dot dr, where r goes from r1 vector initial to r2 vector final, and where v goes from v1 to v2. Otherwise, if you evaluate the integral dv, it will be v. So therefore, v2 minus v1 on the left hand side is equal to negative of e vector dot dr vector between r1 vector to r2 vector. So ಈ ಫಾರ್ಮುಲಾವನ್ನು ನೀವು ಡೈರೆಕ್ಟ್ ಆಗಿ ಬೈ ಹಾರ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಸ್ಪೆಷಲಿ ಜೆಇ ಮೇನ್ ನೀಟಿಗೆಲ್ಲ ಬೇಕಾಗುತ್ತೆ. ಸೊ ಈಗ ನಮಗೆ ಕೊಟ್ಟಿರ್ತಕ್ಕಂಥದ್ದು ಏನು, ಇ ವೆಕ್ಟರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 25 ಐ ಕ್ಯಾಪ್ ಪ್ಲಸ್ 30 ಜೆ ಕ್ಯಾಪ್ ಕೊಟ್ಟಿದ್ದಾನೆ. ಆಮೇಲೆ ಡಿ ಆರ್ ವೆಕ್ಟರ್ ಇದೆಯಲ್ಲ, ದಟ್ ಇಸ್ ಡಿ ಎಕ್ಸ್ ಐ ಕ್ಯಾಪ್ ಪ್ಲಸ್ ಡಿ ವೈ ಜೆ ಕ್ಯಾಪ್. ಹಾಗಿದ್ರೆ ಇ ವೆಕ್ಟರ್ ಡಾಟ್ ಡಿ ಆರ್ ವೆಕ್ಟರ್ ಏನಿರುತ್ತೆ, that is 25 I cap plus 30 J cap dot dx I cap plus dy J cap. ಈಗ you know how to take the dot product. I cap coefficient ಅನ್ನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡೋಣ, J cap coefficients ಅನ್ನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡೋಣ. ಆಗ ಸಿಗೋದೇನು ಅಂತಂದ್ರೆ 25 dx plus 30 dy. Therefore, potential difference between 2 points. ಯಾವ ಪಾಯಿಂಟ್ ಅದು, v1 ಅಂತಂದ್ರೆ ಇನಿಷಿಯಲ್ ಪಾಯಿಂಟ್ ಒರಿಜಿನ್, v2 ಅಂತಂದ್ರೆ ಫೈನಲ್ ಪಾಯಿಂಟ್. ಸೊ ಫೈನಲ್ ಪಾಯಿಂಟ್ as a potential v, we have to find out. Initial point as a potential 0. ಅವನು ಹೇಳಿದಾನೆ the potential at the origin is taken to be 0 ಅಂತ ಹೇಳಿದಾನೆ. So 0 is equal to negative of integral of e dot dr between 0, 0 to 2, 2. So E dot dr ಇಲ್ಲಿ ಗೊತ್ತಿದೆ, ನೆಗೆಟಿವ್ ಆಫ್ E dot dr ಅಂದ್ರೆ ಏನು, 25 dx plus 30 dy between the limits 0, 0, 2, 2. So we'll go one step ahead. So all that remains on the left hand side is v. V is equal to minus, ನೋಡಿ 25 integral of 0 to 2 dx minus 30 dy between 0 to 2. I think these integrations are so simple that I can skip some steps and write the final expression here. Minus 25 into 2 minus 30 into 2, that will give you minus 110 volt. So the answer among the four is fourth one, minus 110 volt. That was really harder problem, I know. Let us move towards question number 12. 3 point charges Q plus 2Q and capital Q are at the vertices of an equilateral triangle. Please change the spelling. The total potential energy of the system of 3 charges is 0. Then so we have equilateral triangle. Bear that in mind. Now the equilateral triangle is matlab 3 charges ಗಳನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ. ಅಲ್ಲಿ ಒಂದು Q, ಇನ್ನೊಂದು 2Q, ಇನ್ನೊಂದು capital Q. The separation distance between the two, R12 is R, R23 is R, or 13 is R, and R23 is also R. All the separation distances are same. You know, potential energy due to 3 point charge system in the absence of the external electric field. We have already noted that formula V equal U. Potential energy expression is U. So U equals 1 divided by 4 pi epsilon naught Q1 Q2 divided by R12 plus Q2 Q3 divided by R23 plus Q3 Q1 divided by R31. ಇದು ಫಾರ್ಮುಲಾ. ಹಾಗಿದ್ರೆ ಈ ಸಿಚುವೇಶನ್ ಅಲ್ಲಿ ಆ ಫಾರ್ಮುಲಾ ಏನ್ ಬರುತ್ತೆ, ಮೂರಕ್ಕೂ ಕೂಡ R12 R13 R23 ಎಲ್ಲ ಸೇಮ್ ಇರೋದ್ರಿಂದ I can take 1 by 4 pi epsilon naught R outside. Q1 Q2 is Q into capital Q. plus Q2 Q3 ಅಂದ್ರೆ 2Q into capital Q plus Q3 Q1 ಅಂತಂದ್ರೆ 2Q square. And that should be equal to 0. ಇಲ್ಲಿ ಈಸಿಯಾಗಿ ನೋಡಬಹುದು. Q ಹೊರಡೆ ತಗೊಂಡ್ರೆ will get 3Q capital Q plus 2Q square is equal to 0. ಅಥವಾ Q ಅನ್ನ ಹೊರಡೆ ತಂದ್ರೆ 3Q plus 2 small q is equal to 0. From this you can prove that Q is equal to minus 3 by 2 capital Q. Minus 3 by 2 capital Q. The answer is the second one. Let's proceed to the next question, question number 13. A point charge capital Q, small q, is at r is equal to 2r from the center of a charged conducting sphere of charge capital Q, with capital Q being very large in comparison to small q, and radius capital R. Another charge minus q by 2 is at a distance r is equal to 2r. If A is the separation between the two charges, then the potential energy of the system of the charges is okay. So here we have a conducting sphere. One conducting sphere is the radius of r ಇದೆ. ಈ ಕಂಡಕ್ಟಿಂಗ್ ಸ್ಫಿಯರ್ ಮೇಲೆ ಇರತಕ್ಕಂತ ಚಾರ್ಜ್ ಕ್ಯಾಪಿಟಲ್ Q ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಇವಾಗ ಇದು 2r ಡಿಸ್ಟೆನ್ಸ್, ಇದನ್ನು 2r ಡಿಸ್ಟೆನ್ಸ್. ಈಗ ಎರಡು ಚಾರ್ಜಸ್ ಗಳನ್ನು ನೀಡಿದಾನಂತೆ. ಒಂದು ಕ್ಯಾಪಿಟಲ್ Q ಸ್ಮಾಲ್ q, ಇನ್ನೊಂದು minus q by 2 ಇಲ್ಲಿ ಇಟ್ಟಿದ್ದಾರೆ. And the separation between the two charges is A ಅಂತ ಹೇಳಿದ್ದಾರೆ. A ಅಂತ ಹೇಳಿದ್ದಾರೆ. So what is the potential energy of the system of charges? Very easy. ಈಗ ಇಲ್ಲಿ ಚಾರ್ಜ್ ಕಂಡಕ್ಟರ್ ಇರೋದ್ರಿಂದ ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಅದ್ರ ಪೊಟೆನ್ಶಿಯಲ್ ಎಷ್ಟಿರುತ್ತೆ ಅದನ್ನ V1 ಅಂತ ಕರೆದ್ರೆ you get capital Q divided by 4 pi epsilon naught into 2r. ಅದೇ ರೀತಿ ಇಲ್ಲೂ ಅಷ್ಟೇ, the potential V2 is equal to Q divided by 4 pi epsilon naught into 2r. We know when two point charges are placed in the presence of the external electric field, the potential energy U is given by Q1 V1 plus Q2 V2 plus 1 divided by 4 pi epsilon naught Q1 Q2 divided by R. So you will see Q1 is plus Q. V1 is capital Q divided by 8 pi epsilon naught R. Plus Q2 is minus Q by 2 into capital Q divided by 8 pi epsilon naught R. Plus 1 by 4 pi epsilon naught. Q1 is Q, Q2 is minus Q by 2 divided by separation distance between the two is A. So simplify this and you will find one among the four choices is the correct answer. Probably that will take some time for me to solve it. Okay, we'll solve it. So that gives you, look, this is Q divided by 8 pi epsilon naught. This is Q divided by 16 pi epsilon naught. So these two together solve to give you Q's capital Q divided by 16 pi epsilon naught. And this one will give you minus Q square divided by 8 pi epsilon naught A. So I think that is, if you can bring the 1Q outside, 4 pi or 8 pi epsilon naught R out. So what remains inside is Q divided by 2R minus Q divided by A. So that would be the final expression. You can check that out. Let us now move on to the next question, question number 14. two charges 7 microcoulomb and minus 2 microcoulomb are placed at 9 centimeter comma 0 comma 0 and plus 9 centimeter comma 0 comma 0. Okay, external electric field of magnitude E is equal to A by R square, where A equals 9 into 10 to the power of 5 coulomb per meter square exists. The electrostatic energy of the system is. ನೋಡ್ರಿ ವಿಚಾರ ಹೇಳ್ತೀನಿ ನಾನು ಏನಂತ. ಇಲ್ಲಿ y ಆಕ್ಸಿಸ್ ಇದೆ, ಇದು x ಆಕ್ಸಿಸ್ ಇದೆ. ಎರಡು ಪಾಯಿಂಟ್ ಚಾರ್ಜಸ್ ಗಳನ್ನ ಇಟ್ಟಿದೀವಿ ನಾವು. ಒಂದು at minus ಇಲ್ಲಿ 7 microcoulomb ಚಾರ್ಜ್ ಇಟ್ಟಿದೀವಿ. So the position is minus 9,0,0 in centimeter, and another one you have kept minus 2 microcoulomb plus 9,0,0. Now there exists an electric field which varies radially, and the electric field value nodi is given by 9 into 10 to the power of 5 divided by r square. You know, this looks like the electric field due to a point charge. Electric field due to a point charge is q divided by 4 pi epsilon naught divided by r square. ಹೀಗಿರುತ್ತಲ್ವಾ? ಸಪರೇಟ್ ಆಗಿ ಬೇಕು ಅಂತ ಬರ್ತಿದ್ದೀನಿ. ಹಾಗಿದ್ರೆ ಎರಡನ್ನೂ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ q by 4 pi epsilon naught ಏನಾಗುತ್ತೆ? 9 into 10 to the power 9 ಆಗುತ್ತೆ. ಸರಿ ತಾನೆ? ಅಲ್ಲ, 9 into 10 to the power 5 ಆಗುತ್ತೆ. ಎರಡು ಕಂಪೇರ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. ಯಾವುದನ್ನ ಕಂಪೇರ್ ಮಾಡಿದ್ವಿ ನಾವು? ಇವೆರಡನ್ನು. q divided by 4 pi epsilon naught is 9 into 10 to 9, 9 to 5. So therefore potential, this electric field is definitely that due to a point charge. And the potential is also due to the point charge. Lellu helilla question alli the field is produced by a point charge anta. But looking at the expression of the electric field, you should be able to come to the conclusion that this electric field is caused by a point charge. So therefore the potential is also that due to a point charge, which is given by 4 pi epsilon naught into small. q by 4 pi epsilon naught ಕೊಟ್ಟಿದ್ದಾನೆ 9 into 10 to the power of 5 divided by r. So ಈಗ v1 ಎಷ್ಟು? v1 is the potential here and v2 is the potential over there. v1 v2 ಹೆಂಗ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀರಿ? v1 is the potential at this distance. Obviously the point charge is here. We don't know what the charge is. Keep that q. So that point charge would produce the potential v1. v1 is given by q divided by 4 pi epsilon naught into r, or r1. q is 9, so q by 4 pi epsilon naught is 9 into 10 to 5. r1 ಅಂತಂದ್ರೆ 9 centimeter, 9 into 10 to the power minus 2. That will give you 10 to the power 7 volt per meter. ಅದೇ ರೀತಿ v2 ಇಲ್ಲೂ ಸಹ ಸೇಮ್ ಡಿಸ್ಟೆನ್ಸ್ ಇರೋದ್ರಿಂದ that is also 10 to the power 7 volt per meter. ಈಗ ನಿಮಗೆ ಏನು ಮಾಡಬೇಕು? You have to find the total potential energy of the system. Total potential energy of the system is q1 v1 plus q2 v2 plus 1 divided by 4 pi epsilon naught q1 q2 divided by r. q1 ಅಂದ್ರೆ ಎಷ್ಟು? 7 micro, 7 into 10 to the power minus 6 into v1 ಅಂತಂದ್ರೆ 10 to the 7 plus q2 ಅಂತಂದ್ರೆ minus 2 into 10 to minus 6 minus 2 microcoulomb ಅಂತ ಹೇಳಿದ್ದಾರೆ into v2 ಅಂದ್ರೆ ಎಷ್ಟು? 10 to plus 7 volt plus volt per meter ಅಲ್ಲ volt, yeah, volt into 1 by 4 pi epsilon naught 9 into 10 to 9. q1 ಅಂತಂದ್ರೆ 7 micro, q2 ಅಂದ್ರೆ 2 micro, ಮೈನಸ್ ಇದೆ, ಸೊ ಮೈನಸ್ ಸೈನ್ ಅನ್ನು ಇಲ್ಲೇ ತಗೊಂಡ್ಬಿಡೋಣ, ಮೈನಸ್ ಸೈನ್ ಅನ್ನು ಇಲ್ಲೇ ತಗೊಂಡ್ಬಿಡೋಣ, ಮೈನಸ್ ಇಲ್ಲಿ ಬರುತ್ತೆ into 10 to minus 14 ಅಲ್ಲ minus 12 divided by r ಅಂತಂದ್ರೆ 9 and 9 18 centimeter, 18 into 10 to minus 2. So 9 ones are 9 twos are a2 ಮತ್ತೆ a2 ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. So ಇದು ಮೇಲ್ಗಡೆ ಹೋದ್ರೆ 10 to the power plus 9 and 10 to the power of minus 10. So altogether this will give you 0.7 ಅಲ್ಲ 70. First term gives you the first term gives you 70, the second gives you minus 20, third one gives you 7 ಉಳ್ಕೊಳ್ಳುತ್ತೆ ಅಷ್ಟೇ, 7 into 10 to the power, so minus 0.7. So 70 minus 20.7, which will give you 49.3 joules, approximately 50 joules. So 49.3 joules, answer is the first one. We will come to the last question now. 2-point charges plus 20 nanocoulomb separated by a distance of 1 angstrom form an electric dipole. This system is placed in an external uniform electric field of 300 kilovolt per meter in a stable equilibrium configuration. The work done to slowly rotate it to unstable equilibrium configuration is given. So first, two charges are there, 20 nanocoulomb plus or minus 20 nanocoulomb separated by 1 angstrom distance. Again, the dipole moment is dipole moment is 2a times q. 2a ಅಂತಂದ್ರೆ 1 angstrom. 1 angstrom is 1 into 10 to minus 10. Q ಅಂತಂದ್ರೆ 20 nanocoulomb, 20 into 10 to minus 9. That will give you 20 into 10 to minus 19 coulomb. Coulomb meter. That is the dipole moment. ಆಮೇಲೆ uniform electric field is 300 kilovolt per meter ಅಂತಂದ್ರೆ 3 into 10 to the power 5 volt per meter ಅಂತ ಆಗುತ್ತೆ. And the dipole is in stable equilibrium. Suppose electric field is initially that way, the dipole plus q and minus q charge, dipole moment is that way. Now you have to slowly rotate it anti-clockwise so that in the final configuration the dipole will orient this way. Plus q here, minus q over there. Dipole moment is opposite. So here theta is equal to 0 and theta is equal to 180 degree. You know the potential energy of the dipole in this configuration. That potential energy U1 is equal to minus PE. I have already spoken about this in my earlier synopsis class. You know the potential energy of the dipole in this configuration. That is U2. This is stable configuration. This is unstable configuration. ನೆನಪಿದೆ ಅಂತ ಅನ್ಕೊಂಡಿದ್ದೀನಿ ನಾನು. ಒಂದು ಸ್ಟೇಬಲ್ ಆಗುತ್ತೆ, ಇನ್ನೊಂದು ಅನ್ಸ್ಟೇಬಲ್ ಆಗುತ್ತೆ. U2 is therefore plus P. And what is the work done? Work done is always the change in potential energy. Final potential energy U2 in this configuration minus initial potential energy U1 in that configuration. U2 minus U1, that is PE minus of minus PE. So that gives you 2PE. That is the work done. So we will calculate that work done. 2P. Therefore, work done is equal to 2 times P ಅಂತಂದ್ರೆ 20 times 10 to minus 19 ಅಂತ ಬರ್ದಿದ್ದೀವಿ coulomb meter. Electric field is 3 into 10 to the power 5, 20, 40, 43 are 120 into 10 to minus 14 joules. That's what 1.2 into 10 to the power minus 12 joules. So 1.2 picojoules. So the answer among the four in terms of femtojoules ಕೇಳಿದ್ದಾರೆ. Femto ಅಂದ್ರೆ ಹಿಂಗೆ ಬರೀಬಹುದು 1200 into 10 to the power minus 15 joules. 10 to the power minus 15 ಅಂದ್ರೆ femtojoule. So 1200 femtojoules. So answer among the four is 1200. Answer number 3. With this, my dear students, I have come to precisely the end of electrostatics. Actually, I was supposed to take 3 sessions in this CET, in these CET classes. However, because of certain pressing issues, I was not able to take up the first session. So I took the second and third. Whatever I was supposed to take up in these 2 topics, in these 2 sessions, I have taken. The whole electrostatics is basically over. In case I am assigned one more session, idr mele innond session assign madkonಡ್ಬಿಟ್ರೆ, we will have to just talk about problems. Another 30 problems or so will solve in the upcoming. That makes this electrostatic session absolutely complete. And a certain section of it is remaining, which is capacitor. We thought it is better to be adjusted with the current electricity. That is the reason why it is placed with under current electricity. I'm sure you will enjoy Vignesh Bhatt's class on capacitor and electrostatics. As for my class, this would be my last session on electrostatics. Have a nice day. Goodbye. And I also would like to thank Zilla Panchayat and its honorable CEO and all its staff and the persons who are in charge of these classes, Mr. Dr. Madoli and Mrs. Sahana and many others, to name a few. I thank all of them and thank you all. Goodbye and have a good day.